All right, let's review real quick on the engage, and then we'll go over the quick content in a moment. So first we had our calculator output here. We're familiar with this. A is our slope, B is our y-intercept. So we get 1.803x plus 70.127. That's our equation of best fit. Then we can directly read our R value, our correlation coefficient, that's 0.1116. So this tells us two things. One, it tells us it's a weak association. And two, it tells us that it is a positive association. So this tells us the strength of the association, and it also tells us the direction. So that's how we interpret this calculator input. We're familiar with that. So the quick new content builds directly off of that, and it is this computer output. So with this computer output, it's just another way that a computer might calculate this as opposed to your calculator. On the AP tests and college assessments, you'll see you're just given the computer output here. And then you need to interpret this to answer questions like 1 and 2. So let's dive into that. First off, if I read through some context here, it's volume versus height, and then I get an equation here where it's volume equals negative 87.1 plus 1.54 times the height. So volume would be what we're predicting, equals negative 87.1 plus 1.54, and then the height here would be our x value. So height is the explanatory variable, whereas volume is the response variable. So with that, the super important column is the coefficient column. This is going to help us write our equation of best fit. So conveniently, they gave it to us here. We're not always going to see that. Sometimes we'll have to interpret it from here. So this first part, this is negative 87.12. That's our constant. So that's going to be our b value, or our y-intercept. And then the coefficient on the height, this will be our slope. And that's 1.5433. So if we combine those, we get negative 87.12 plus 1.5433x. We see this equation closely matches this part here. Then we're asked to find the correlation coefficient. I remember that the correlation coefficient is represented by r. So we need to find r somehow from the data up here. What I'm going to zoom in on is the r squared value here. This represents r squared, which is the squared version of r. So this is r squared equals 0.358. But we need to find r, so we're going to take the square root of that, 0.358. When we take the square root of that, we find that is equal to 0.598. 0.598. And remember, this tells us two things. This tells us it's a slightly strong association. And two, it tells us that it is a positive association. This would not be true if our slope was actually negative, but because our slope's positive here, we know that this would be a positive association. If this was a negative slope here, we would want to interpret that r value as the negative 0.598. Because it's positive, we know this is positive. So that's how you can read a computer output to determine your equation of best fit.